this will finish chapter 4, and it's pretty straightforward. And I mean, it all starts with this. Newton's method is an iterative method that, with your initial guess, it will give you another value as your next initial guess. So let's say your first guess is off by a factor of, say, 10. You plug that in the formula, work it out, it'll give you another value that's getting closer and closer and closer to the actual result you're looking for. So that's what this thing's all about. And that's why it's very labor intensive if you don't have a computer. And that's what we're going to do real short, quick and easy examples. Yeah, so.
Do a lot of computers actually apply
your calculators, everything. For example, the first example we're going to do is the square root of 2. What algorithm that calculators use is Newton's method, because it just you have to figure out a way. How does it do it? There's no real formula. What is the square root of 2? It has to do something to get to that value, and this is what pretty much what it does.
When you take your initial guess, like maybe the square root of 2 equals, well, we know what it equals, but maybe we say it equals like 1.5.
Yeah. Oh, the initial guess is the most important. The farther off you are from your solution that you're really going to go for, the more iterations it takes. You'll get to it eventually, but even if your solution is in the negatives and you start off with a positive, it'll eventually get there. Or if it's too far in the negatives, it'll eventually get there. And I'll show you how it works. It's the way it works is super fascinating. It has to do with tangent lines. Yeah, it's tangent lines to a curve. So in other words, it starts off with the slope of a curve. Where if you wanted to, we could use functions. And what's another way of writing the slope in calculus? Derivative. Very good. We can say it's the first derivative. Because what we're looking for here, we want to solve for y. Y is the f of x. So in other words, we want to solve for that value there. So how do we do that? We first have to get rid of the fractions. So multiply both sides by x minus x1. So we have f of x minus f of x1 equals f prime of x times x minus x1. Since we're trying to get y by itself, we have to move that over. So we add f of x1 to both sides. And remember, f of x is the same thing as y. So we have y is equal to f of x1 plus f prime of x1, x minus x1. As you can see with this, we have x1 that's in there. X1 is your initial guess. So in other words, if we plug in, let's go back to this format. If we plug in x1 here and work all this stuff out, what we'll get is the value of y, the next level. So that value at that x will give us that next solution. And then whatever we get there, we plug it back into the equation and keep on doing it until we get close to a number that doesn't change anymore. So this equation is equation of a slope. But more so, the slope of what? What exactly is that a slope of? Right. It's the slope of the line tangent to a curve at a given point. And that right there is going to be very integral in what we're doing here. Now, if we set this thing equal to 0, because we're looking for where it crosses the x-intercept. So we have f of x1 plus f prime of x1, x minus x1. So now we're going to solve for x, because we're looking for the x-intercept. We set y equal to 0, now we solve for x. So move this one over first. So we have negative f of x1 equals f prime of x1, x minus x1. Divide both sides by f prime of x1. Those cancel. So we have x minus x1 equals negative f of x1 over f prime of x1. What's my last step? I have to add x sub 1 to both sides, right? So my value so this is the formula for my x values. Now, because remember, it's iterative. If these are all x1, what does this one become? If these are all x1s, this one's x2.
What is the f prime of x? Is that x1?
Yes. Because you have to come up with the initial value first, initial guess x. Once you get that, then we could find the value of f of x and f of x prime. Because remember, we have to start off with a function. And we find the derivative of that function. And that is what we plug in there. So the general form of this equation, of all of these equations actually, is, since this one's bigger than that one, this is x n plus 1 f of x sub n, f prime of x sub n. And these are, with whatever x n we put in there, we put them in there, find the functions, the derivative in the original one. That way, plug it in there, take our initial value, subtract it by this ratio, that gives us our next value. Then we take that value, plug them in here, that gives us this, and then so it keeps on going. Now, here's the cool thing about what it does, how it works. Because all you have to do is push that ball or that rock off the cliff and it goes on by itself. It'll generate the next value of x. So let's pretend we have a function. Here. Actually, that's not right. Let's go to this one because I need to have an x-intercept right here. That's my solution. That's what I'm looking for. This is called the root. Eventually, your solution, this is the x-axis. And that's the y. All right? We don't know where it is. So we pick a value of x. This is x sub 1. Or actually, let's start off with x sub 0 because we have an initial start. Well, no, wait. So this will map to that point, right? Now, we take the first derivative, that finds us the equation of the line tangent to that curve. This is now our next x value. So we take the first derivative, find the equation of the secant line, find out where the x-intercept of that line is. That is our next value of x. So that gives us so at this point we have x0 f of x0. Now we have another point where this crosses the x-axis. That's our next x value. We repeat the process. This is my x sub 2. And that gives us x sub 2 f of x sub 2. This is x sub 1 f of x sub 1.
So your new value of x1 from x0 is going to be whenever it crosses.
The x-axis, because that's where it's going to give you the new x. So this one here, give me this tangent line, the slope,
The derivative.
the derivative, and here's the x-intercept. So now I use that. Because you notice every time it's getting closer and closer and closer to our solution.
So when the slope of that new or that initial one becomes zero or when it crosses the x-axis.
Right.
X equals
When there is no more of points. There's as f of x goes to 0. Kind of like the limits. Because this is kind of what it's, I think this is a better way of showing as x gets closer to c, f goes closer to 0, the limit. So now this one, it gets even more shallow. Finally, eventually, when we get to our value, because what we're looking at here is these values will get closer and closer to our solution point we're looking for. And you'll notice, because if you keep on going past that point, the slopes will change from positive to negative, or it'll start going further away. This is what we're talking about. Convergence versus divergence. As long as it's heading to a specific number, it's converging to that point. If it's going away, if it's getting bigger and bigger and bigger, then it's diverging. Let me look for, here's the first example. But no, that's what I'm saying is, this is a very beautiful method. That's just whatever x value we start off with. I mean, even if we started off over here, so even if we had our x value over here, if our initial x value, it's self-correcting, because at that point it'll put an x value over here, and then we'll get back to where we're supposed to be.
When you plug that value of x into your initial guess, let's say it is x0, right?
Right.
And then you plug it into that formula, xn plus 1 equals xn minus
F of x minus f prime, right?
Then it gives you your next value.
Mhm.
Okay.
Yeah, because for our y equals f of x 1 minus, I think it was the same thing. Where's that? Oh, I know that. It's plus, yeah. Plus f prime of x, x minus x1. So this will find that this is our function, the y values. Once we get the x values, we plug them in there. So the x values, let's say this is 1, we start off with x0 minus f of x0 over f prime of x0. So we plug our initial value here, that gives us the x value. We plug that in here, we go. The next time now, we're going to be looking for f of x2. Well, this will find us f of x2. Because we used x1 for all these, this gives us the next value. So then our next time through this, we'll increase the counters. So now This x2 will go into this side. I'll start off at, that's my initial guess. I put it inside the functions. And that's going to give me x3. That's going to give me x3. And then that x3 is my initial guess next time. That will give me x4. So this becomes my initial guess next time, my initial guess, and that goes inside the functions.
And so that's why it works so perfectly for computer applications.
Right, because it just does it automatically. Right. And you could, but here's a problem we have with computer systems, so calculators. It's called the level of degree of accuracy. The more decimal points you have, the more accurate you become. Your calculator screen has what, maybe 8, 7 or 8,
It's up to
9. Yeah, so anything greater than that, if you had 15, 20, or 30, or 100, you'd become a lot more accurate. Because then you start seeing the numbers start getting approaching a specific value. If they're all going to be 0.7s or 0.9s, you'll see that occurring.
But sometimes those patterns only occur after a few,
Oh yeah,
dozen digits.
right. And it all depends on how accurate your initial guess is. That's why the best thing to do first is graph the function, plot it, see what you have, and then approximate one of the values. So it's a rule of thumb guess. And then from there, I say it's going to be self-correcting. But the further away you are, the more iterations it'll take to get there.
So if, for example, we knew a point on the graph, and we didn't know another point, and we want to find it, then that's what we can use this for.
Mm-hmm.
Okay.
So let's look at our first example. Because this section, unfortunately, doesn't have too many examples. Approximate the positive root of the equation f of x equals x squared minus 2. Okay, so our first derivative of this will be 2x. And we'll set our original function to 0. So x squared equals 2, square root both sides, x equals plus or minus square root of 2. We just want the positive. So this is what we're approximating. We're approximating the value of square root of 2 using this process. So remember, our formula that we'll be using for our x values is n plus 1 equals x sub n minus f of x sub n over f prime x sub n. That's our formula we'll be using. Okay, let's plug in what we know so far. So we have x sub n. F of x sub n is x squared minus 2. That's that one. Over 2x. Well, these are all x sub n's. Get a common denominator. Let's simplify this equation. Well, we have this equation here first. We can split these up. X sub n squared over 2xn plus 2 over 2xn. Rather, that's a difference equation. So I distributed the negative inside there. This xn cancels with one of those. We have x n over 2 plus 1 over xn. Can we go any further? This is 2 over 2, so it's 2xn minus 1xn is xn over 2 positive. You could leave it like that, or you could get a common denominator, or you can go, it'll be x squared n plus 2 over 2xn. You could do that. Either one, doesn't matter. Get a common denominator. So here's where we start. Now, what is our first value we're going to begin with? We can't use 0 because the bottom has the xn. So we start with xn equals 1. Let's see what happens there. So our initial value when x sub 0, we're going to say xn equals 1. So x sub 1 is equal to 1 over 2 plus 1 over 1 equals 3 over 2. What do we do with that? Yeah, so now my x sub 2, it'll start off with x sub 2 over 2, so it's, or x sub 1 over 2. So it's going to be 3 over 2 over 2 plus 1, 3 over 2. It may be easier keeping it in fractions. This is 3 over 4 plus 2 over 3 is 17 over 12.
Four, one, six, six.
So you see, from here on out, using calculator is the way to go, because instead of putting them in fractions and just getting more ugly, we'll just plug those in there. So x sub 3 equals 1.416666 over 2 plus 1.14166666. And this one I have here somewhere. 1.4142222222. Around there. So we keep on doing that. So in your calculator, type in the square root of 2. What is the square root of 2? What's that? Yeah, so if you notice, it's getting closer. It used to be 1416, now it's 414. We do it a couple of more times, and it'll become more and more accurate.
Really, seeing the genius behind this.
Mhm. Yeah, so if you notice, we took the functions and put it in place just for the x value. So it's just going to do it itself.
I mean, they did.
Oh, yeah.
That's what's crazy about.
Exactly. They did this in paper. And I mean, think of this. These fractions. They would have to go through and just do all these fractions over and over and
Just
over.
the intermediate, like computations, like you have to first solve 17 over 2 by using long division. And then
Yeah.
finally see a point in which it repeats or terminates.
Exactly. Exactly. So you're looking at the hour is very labor intensive. Oh, and mostly in engineering and any type of the sciences. Mhm. Or even in business, you're gonna see at what point, this is how many items you're gonna have to produce. You do the same thing with your cost and in production, your profit margin, and see exactly where is it, how many do I have to do? What's the most money I can make with this product? And it's gonna tell you, it's just by saying, by producing this many, after that, it's unknown whether it's gonna lose money or gain money, so. Yeah, it's pretty powerful, it's the same. All right. So let me look for example 2. Where's example 2? There it is. Okay. Find the x coordinate of the point where the curve y equals x cubed minus x crosses the horizontal line y equals 1. So again, we have our formulas that we'll be using. Xn plus 1 is equal to Xn minus f of Xn over f prime of Xn.
And so instead, in this case, we're setting the derivative equal to one. Right?
Well, we're setting the function equal to 1. Because remember, the derivative is simply the slope. So this function, we want to know when it equals 1. Remember, it says find the x coordinate of the point where the curve this crosses the horizontal line there. So
it's x cubed minus.
yeah. Oh, I see what you're saying. Yes.
Okay.
But in order to find these, we still have to find the derivative and stuff. Just to use this formula. Actually, let's look what happens here. We have, it has to be set equal to 0, x cubed minus x minus 1 equals 0. So what can we do? So in other words, this is our new function. So we're setting the function equal to 0. So in other words, our function is x cubed minus x minus 1. So we have to figure out a logical starting point.
You would have, so it can't, it's not gonna be an. So we have to guess maybe like.
Well, let's plug in some points. Let's see. At f of 0, we got -1. And 1 would be the, so at 1, it'll be the same value. It'll be same -1. How about f of 2? So we know that at 1, it'll be -1 also. At 2, what do we get? 2 cubed is 8. Minus 2 minus 1 is +5.
So we know basically that it's between f of 0 and x.
No, because
I mean,
between f of 1 and x equals 1 or 2. So it has to be between 1 and 2. What's that theorem that tells us that? Intermediate value, very good. Intermediate value theorem, because if at negative, we have -1, at 1, we have a +5 and they're connected, it has to have an intercept there somewhere. And the line we're going to cross is the line at y equals 1. So let's go ahead and pick our x sub 0 as being 1. Okay, so we need to know our n, our f of x sub n, our f prime of x sub n, and our x plus 1. Let me just do it down here so I have more room. So we need to have x sub n. We have to find our function at that value. The value of the function at f prime and our next function, which is x sub n minus f of x sub n divided by f prime x sub n. Okay, so far so good. So our f of x is what? I'm gonna do the, yeah, you're absolutely correct. It's f of x is x cubed minus x minus 1, and the f prime is 3x squared minus 1. And so our first at x sub 0 will start with 1. Here's our n's. Here's at 0, 1, 2, 3, 4. So when x sub 0 equals 1, we're starting off with our initial guesses being 1. So f of x sub 0, plug in 1 inside the function. 1 minus 1 is 0, it's negative 1. Plug in 1 inside here. 3 times 1 is 3 minus is 2. So f prime at x sub 0 is 2. So x sub 1 will be equal to x sub 0, which is 1, minus negative 1 over 2. 1 plus 1/2 is 3 over 2, or 1 over 5. I guess we could do a spreadsheet with this. This will also work. It wouldn't be as accurate, but because this value here now goes over here. That's our x sub 1. Let me do that. Let me see here. I'll just make this a spreadsheet because I would never ask you guys to do this on pencil paper because it's just going to get more and more ugly.
Newton might ask us to do it.
Yeah, I said, I did it. Why can't you? Okay, so this is n. This is x sub n, f of xn, f prime of xn, x n plus 1 is equal to xn minus f xn divided by f prime xn. So this is 0, this is 1, this is 2. And we'll build up there. So our initial value was x equals 1. So f of x n equals x cubed minus x, no, E5 cubed minus E5 minus 1. I can do it here, I'm sorry. And this one is 3 times E5 minus 1. And this one is E5 minus F5 divided by G5. And that's going to be whatever this is. Oop, okay.
Move from giving it a heart attack.
There, now you see how accurate we're getting? But you see, we're now getting more, it's 1.324715659. Let's see what happens here further. You see a pattern there?
So it's, so it really stops changing after.
Yeah, at 15 or 16, right? So that's our solution. But again, that's not, doesn't make it. With programming languages, you could change the degree of accuracy.
Right, you're gonna have to go out to, you know.
You say, yeah.
precision.
Well, yeah, and that's even limited because what you want to do is make got to be 100, 200 decimals. So that's why.
like science fiction.
Well, see, that's where we use at graduate school. Use the Cray computer in Austin. So, and we just start the program at 10 o'clock at night. Come back next morning and pick up your results. So,
It's got, you know, who knows.
but yeah, this is what you see. Once eventually it'll converge, and it converges to the same value. So we know that the value 717,318 go. This is what you're looking at. You're looking at these values until it converges to a value. And then that tells you how many iterations you have to do it. No. And that's all there is in that section.
There's not too much to it, I mean.
No, but it's complex if you have to do it by hand.
Right.
That's why I say never do it by hand. But understanding what this principle, that this method is pretty powerful.
Yeah, I had no idea about the tangent lines and how that was like the actual reason for it.
Yeah, and that's exactly why you start off with that. Now you have tangent line. It has to serve a purpose. Wherever it crosses the x-axis, that's your new x value. It's genius the way they thought about it. Eventually, it'll, no matter where it goes, it'll you get closer and closer and closer, closer, closer. Eventually, it'll go down to the limit point, which is what you're looking for.
Because if the tangent line is over in the negative section, then it's, the tangent line is still gonna be positive, or the slope is still
So
gonna be positive.
exactly, it's going to point, and then it'll start back there, like we just saw earlier. It's just eventually going to go back to where it's supposed to. It may take a little bit longer than previous, but
But I mean, if you have a supercomputer doing it, then
it wouldn't matter, right? And this is a pretty simple, straightforward equation. But yeah, that's why the initial guess, initial start is the most important part.
So can you show me the notes that you,
The what?
the notes?
The notes?
That's the new one, the last one that we did.
Oh, not this class?
Oh, no, the last one, the just now.
Here, here's everything.
Yeah.
Okay, now what I want to talk about is, let's look at using AI. So when you go home, what you're going to do is you're going to go to chat.openai.com. No, or you can just Google Chat GPT and it'll take you here. This is the chat window. Originally, when you first start off, you'll be in Chat GPT 2 or Chat GPT 3. These two are the paid versions. This is the beautiful thing about Chat GPT 4. See, I'm in Chat GPT Plus, is 3 is very fast and it gives you great information. It'll even create tables. Like if you say here, create a table of the top 5 football teams with the headings of team name, location, and number of Super Bowls won. And it'll go in there and give you the breakdown of it. So again, it gives you a table. Not many AI chatbots will do that.
I noticed you have to be pretty specific about the top 5 for what, because that might be what its concerns.
Yes, because yeah, at first I'm just gonna give you just a basic introduction. Let's see how you go from there. But then on Monday, I'll give you a formula for the optimal types of prompts. These are what you type in here is called a prompt. That is the directions you're given. Think of it this way: you're a king of a kingdom, and you want to tell your subjects to do something, or your servant to do something, and the servant knows nothing. You have to tell him everything about it. You have to tell him, okay, do this. You are this. Do this. I want this as an output. I didn't know that. Wow.
That was,
I mean, they use floating, right? They use floating.
I mean, that was their lawyer.
Because my mom always used to say that one.
Yeah, and mid, like 1960.
Yeah, and it's
Because it's 70s, right?
Well, this is from the beginning. It's just a number of Super Bowls won.
This was one of the oldest teams.
I believe so. Because, yeah, they were back around when they didn't have face masks. And Dallas Cowboys used to be called the Washington Senators and when the league first began. Then they switched over to the American football and American League. So, okay, so that's you can see that's GPT 3.5. Now, the thing about Chat GPT 4, you have to pay for this one, but you see down here, it gives you DALL-E is a AI tool that allows you to create pictures just by describing words. Well, yeah, if you do DALL-E, we'll look at that also, because you can make it create pictures. Actually, I can show it to you in a little bit. My portfolio for my doctorate's program and what I created a bunch of avatars that started off with me, and then I told it, use my picture, now transform it to a pirate, and it gets older as I go along. So now with these like plugins, you can pick whatever ones you want to put in there.
Oh, it has both.
Yeah, this
I didn't
is,
know. I've never looked at the plugins.
and all of these have different, this one draws diagrams. This one, you can upload a PDF and ask it anything. You just upload an article, a research article. Said, okay, tell me the hypothesis, tell me the question, tell me the conclusion, sample. In other words, I don't want to read this 18-page report. Summarize it to me in half a paragraph. You have diagrams, bar charts, graphs. You have the Google Earth. Perfect prompt is what I'm playing with now. Is you type in the word perfect in quotes, and then anything you type in afterwards as a prompt, it'll make it a perfect prompt to maximize it. And you have AI diagrams, smart slides. This creates PDF slides for presentations for you with pictures and everything. And Document Maker is, again, you tell it what to do, it'll create a Word document or any other type of document you want. But yeah, right. And there are, we'll come down here. You can look at your custom instructions. And you can look at what you want to log in there. Because all this stuff you have to activate first. But this is the one you have to pay for. And as much as I use it for my research, I really don't mind. But when you first get on there, you may not have these options. That's why it's what you type in there. So you have to think. The hardest part about this is you have to think how you would tell someone who knows nothing what you want and what you want them to get. Because it knows everything, but it also knows nothing. Because it'll take it too long to give you everything.
We can't understand.
Right. Well, and that's the hardest part is we're never taught how to ask specific questions. We're asked always to ask general questions. So like here is describe the Newton's method and what is its main purpose? This is true. It's a powerful technique. That's true. This is, yeah, intersection of the y-intercept, yeah. Oh, it even gives you formulas. I did not know it does that. Oh,
Yeah,
this, I'm doing the higher ones, yeah.
I've noticed sometimes in LaTeX.
Basically, Wikipedia is.
Well, it's Wikipedia is not good because Wikipedia people change things.
Yeah.
You can go in there and put the topic could be Abraham Lincoln. You can say he was the first black female senator. And it's gonna stay there because it's only gonna change when somebody else changes it. So it's, this goes into everything. If you want it to, it goes into research articles and looks at all those. It looks at everything. And again, that's what I tell you, you can tell it where to go. Access these research articles or these journals. But again, this is exactly what you have in your textbook. And exactly what I said, this breaks it down to certain steps. And if that doesn't work, set it regenerate. You keep on regenerating it until until you get what you want.
And then you can upvote it, and then it'll change the formula that outputs it, right?
Right.
It weights it on, I don't really know about the statistics, but it does.
This,
Oh,
what's that? Yeah, but it all, think of this phrase, garbage in, garbage out. If you tell it in a terrible format what you're looking for, it'll give you junk. Okay, another one you could look at is Google Bard. The difference between Google Bard and ChatGPT is ChatGPT is only accurate up until its license allows it to get. Google Bard is Google. It's up to the very second. It's from the second the last person put anything online, it activates it. It allows it to come in. Or if you don't like that, then you can go into, let me see, where's that? Let's see if I have it. I'm looking for that new, there it is, Edge. If you look at Microsoft Edge, it has AI built in already. Man, may not have saved it, but it has Bing.
Well, I think as soon as you look it up, it'll actually generate.
Oh yeah, it's right there. Yeah, there's Bing. Search AI. It's a chat bot. So again, here, this is everything it looks at. It looks at Google, looks at Safe Search, I mean, everything. And you have total control of it. Yes. But a lot of people don't like Bing. I mean, not Bing, but they don't like, yeah, Microsoft Bing because, or Edge, because it's too new. Here, now you can ask it anything. It has so many things incorporated in it. It's more powerful than ChatGPT because it'll allow you to not put any extra plugins. It does it all already. So you can use any one of those. Actually, then there are a bunch of other ones. There's Jenny. There's yeah, there's Llama. There's like a dozen of them. It's just that you pick whatever one you want to and ask it. What I want you to do for next time is look at chapter 5, section 1. Let me see, chapter 5, section 1. Your homework for next Monday. Yes, Monday. Besides catching up with everything we're doing now. Is because we have a couple of weeks and only one chapter left to do, we'll do this. Each topic will be a discussion as opposed to a lecture. I'm going to pull up the textbook here. This would be area and estimating with finite sums. Ask it. Learn what you can from any one of the AI tools. Learn as much as you can about area and estimating with finite sums in Calculus 1. There's no wrong answer here. It's just that you're learning how to, and then I'll give you, bring a printout or access, or send me via email this weekend, what prompts you put in there and what it told you. Because once you finish all these prompts and everything, you can copy and paste them and put them onto a Word document. Okay, so once you do that, once you finish it, so send me a copy to my email and I'll look at those before class next week, so that we can talk about those, and I'll print them out also. So no cheating though.
Yep.
I want to see how your brain is thinking, because it took me a long time to get over being polite and I'm almost being apologetic to a machine saying that, okay, if you can, please do this. No.
If it's fancy.
Yeah, I mean, it will tell you, it's got an attitude. It'll tell you, no. I mean, it's doing the work for you for, like, say, an hour or 2 hours. And it says, and you hit regenerate again, it says, oh, that's out of my scope. I can't do that. Because it doesn't want to. You wait 10 minutes, hit regenerate, it starts printing out.
Yeah.
So it has an attitude. You're the controller, you're the human here. So you have to be specific on what you want. Yeah, you see the area and estimating with finite sums. Well, what do you want it to do? What do you want from that? You have to tell it what you want. So think about what do you want to learn from there? What do you want it to tell you? Because you have a free tutor here 24/7. What do you want it to tell you? Actually, and also there are some add-ons you can do that it'll read back to you what it gives you. It'll talk to you.
I think with ChatGPT, they actually introduced.
Yeah, they have it now in ChatGPT 4. You can talk to it and ask it.
And you can select different voices too.
Right.
I think I was playing around with that.
So that's what I'm saying, is that's where you're going, so that in future, all your courses, don't have it do the work for you, but have it explain it to you in a way that you understand it better than everybody else. So that's what your homework is, besides the homework online. For the chapter 5, all the sections, this is what we're going to do. Well, you can pick either AI, any type of AI, ChatGPT, Google Bard, Bing, you get any one of those. And then once you get on there, once you register yourself, because you have to give it an email and everything else, that you have to register, then go in there and just type in a command. Relative to this. I mean, so write this thing down, write it down somewhere, because you have to access this. And have it instruct you. You can even tell it, I'm a 2-year-old child. Explain it to me so I understand. And if you have laptops, bring those next week also. Bring them from now on out, bring them out. Because our discussions are going to be relative to that.
I really believe that the difference in terms of like people's competitiveness in the workforce and stuff is gonna come down to their ability.
I definitely. Well, you heard let me go ahead and kill this. All right, I'm gonna stop recording. Because you heard the